Hi everyone and welcome to a new tutorial. My name is Abdi for asART 3D and motion graphics. In this tutorial I would like to show you how you can create a liquid simulation or water simulation for a backyard pond with a small waterfall like this. Here we're going to create two different simulations of liquids and then let them interact with each other using the cascade simulation. So let me jump into 3ds Max and start setting this up. Here in 3ds Max I already have my pond set up. The original file or model is coming from Evermotion webpage where I purchased that model, but I rearranged the way that they had their waterfall set up. So it is more or less the same thing, but the original setup was causing my liquid simulation to flow to the right side and not just cover everything. And that was the reason why I went in and just rearranged that waterfall a little bit. The next thing was making sure that there are no gaps between these elements so that the water cannot just go and flow out of somewhere. So that was actually my preparation for the liquid setup. And it is also important that all of these elements are free of errors, so you don't have any holes in them and there are no open faces and stuff. And you also make sure that you're going to go and select all of them and then right click, go to Chaos Phoenix properties, and then make sure that the clear inside checkbox is on. And that will kill every single particle that may get generated inside of any of these elements, because we don't need them inside of them. And now what we need is starting to create our liquid grid, or actually the simulator here. So I'm going to draw a grid around these waterfall, then switch to my perspective view, go and turn it around so it is looking or facing the same direction. I go up here and set my pivot to local. So now let me go to the top view again. Maybe we're gonna bring it to this side a little bit. And now if you want to change the size of your grid, that is important that you do that inside of the grid rollout here and not just using the scale or something. So just go into the rollout and set that up like you want it. So now we have about 200. Let me set it to about 210 or something. And the y-axis I'm gonna set it to 450. So something like that. Then I'm gonna bring it up, move it to the side. Sorry, I just accidentally moved the rock. So move it to the side, bring it up again, and then just tilt it or rotate it until it runs perpendicular to your waterfall here. So just like that. Bring it down so it disappears. That means we cover the entire rock here. And then we can move it to the place again. So this is actually what we need. And going to the top, we can move it a little bit forward so that this line, the top line here, starts somewhere behind this rock. So the water will collide with this wall anyways. That is a good distance to it. And here in the front, we need a little bit of space because the water will maybe splash over these edges and then go somewhere. And I don't want him to get killed right away so it looks cut or something. Okay, this is going to be our grid. Now it is too high. We don't need this height right here. So we bring that down a little bit. So about there, this should actually do the job. It's not going over that edge anyways. And now we can take a closer look at its setup. So right now we have 4.5 million particles. This is usually not enough for such a simulation. And there is another thing that you should pay attention to, and that is actually the scene setup, a unit setup of our scene. So just go to the customize and then unit setup. I set it to metrics meters, and then my system unit setup is set to 1 unit equals to 1 centimeters. And when I go and measure my entire waterfall here in my y-axis, that is 4.7 meters. So this is why I changed it to meters and I am not working in centimeters for this setup here. So now the next thing we have to take a look at are the dynamic settings. We will get back to this and change that or actually increase it later on. But for now, I'm going to leave it like this. And in the dynamic settings, we can go and just turn off motion inertia because we don't have a moving emitter in our scene. Gravity, we're gonna leave it as the default. We don't need any initial fill up. And steps per frame, I'm gonna increase it to 2. Time scale, I'm gonna set it to 0.75. The rest of it, we're gonna leave it the way they are because we don't need actually to change the viscosity and the RGB stuff here. We don't have any other liquids that are in different colors and will get mixed to that and so on. So we can leave all the things. We don't have any waves, so we don't need droplets, surfing. And for the surface tension here, we will have to change these values for sure, but we will leave it for now and get back to them. The same for wetting. Now, we go to foam and splash later on, then the output is pretty important that we have our output set to a fast hard drive if any possible. So let me do that right now and change the path for it. And then here the storage quality is set to 14, which is okay. That gives us a good balance between the memory usage and the quality of our cache files. And the backup interval, I'm going to set it to 5. And what that does is it's going and creating a backup after 5 frames. So after each 5 frame, it will create a backup. So when something is wrong, I can just stop it and then go back 5 frames and then re-simulate from there and not be forced to go back to the very beginning and start the entire simulation from zero. This is really, really helpful. And down here, we don't have to change anything else. We can leave all the stuff here as default and go to preview rollout. I usually leave it like this for the beginning and then later on switch to the show mesh mode so I can see what the liquid looks like. But we can actually go and do that right now and turn off the liquids so we will see just the mesh. So the next thing we need is actually creating an emitter for our liquid source. So I'm going to create just a box like this. Then right away I go and right click, convert it to editable poly. Select the top face here, change this ID to number 2, Control I to invert your selection and set everything else to number 1. So the top face has another ID than the rest. This is actually what is important here. because we're gonna go and generate those liquid particles from that surface only and not out of the entire emitter object. So now let me move it to the place here and then move it up and bring it down till you just see that face only. And here we go and right click on it. Go back to Chaos Phoenix properties. Make sure that solid obstacle is unchecked. So the liquid will not go and collide with this emitter here. And in our layer explorer here, we can go and make it unrenderable and show as box. So it will not get rendered in our actual output, and we don't have to see it as a mesh all the time, so we can change it to show as box. Now with that set, the next thing will be adding a liquid source object, and we can go and add our emitter into this, which is our box. Now we have to scroll down and make sure that the polygon ID is set to that number that we just defined before, which was number 2 for the top part, which means it goes and searches for the face with ID number 2 and starts generating out of that face and leaves everything else alone. So now we have to scroll up to the outgoing velocity setup here or value. I'm gonna leave it the way it is, half a meter, which sounds still too high to me, but we will just run the simulation, see where that goes, and then take it from there. So let me just start simulate and come back after that thing is done. And there we have it. Now it is simulated. When I run it, it looks like a wild river rushing down a mountain or something. And that is not what I am looking for a small pond in my backyard. So we have to slow it down a lot and then change all these splashes and get rid of them. So we have actually a creation of a watershed, if you want, so that is slowly flowing down and creates a nice small pond waterfall. So now let's go and change some settings. The first thing we have to change is the speed of it. I'm going to bring it down to 0.12, which is around 12 centimeters per second or so, and not half a meters or something like it was at the beginning. And now let me go and change the surface tension, which will make the liquid stick more together, but it is not a sticky liquid afterwards. It is just holding the particles together or binding them stronger together, so you get a flattened or smoother water surface or liquid surface, and it is not creating those wild splashes and stuff. So I'm gonna set that for now to 0.05 because that is pretty sensitive. And for the droplet formation, I'm going to set it to 0.01 for now. And the droplet radius, I'm going to actually increase it to 6. I don't want them to be that small. So now I'm going to go and resimulate it again. So I just simulated the first around 300 frames, but as you can see, it is much smoother right now, and it also flows not that widely and that fast. So this is looking much better. Now I want this droplets to be still a little bit less. So for this, I'm gonna go and change that formation here to 0.05 and see if that will help. And I'm going to actually reduce that again back to 3 for the droplet radius, so we don't have those big droplets. So let me go and delete the cache and resimulate it. Now that looks better, but if I go here, I don't like this. We can go to the rendering rollout and smooth it out a little bit. So we go to the ISO surface level. I usually set it to 0.63, which makes it a little bit thinner. And then for the smoothness, set that to 2 or 3, so you get a smoother surface. You can also go and use liquid particles and then use the particle size, which makes it even thinner or works with that value actually. But for now, we leave it as they are, but we need more particles. Right now, we only have 4 million or something. So when we go to the grid rollout, we see we have 4.5 million particles, and we have to increase this and then run the simulation again. So let me just kill that cache and start the simulation. And there we have it. That looks actually much better now than at the beginning or before. So now in order to see how the real speed of that thing is, I'm going to create a preview and watch this. And this is now the actual speed of it. Well, which is in my opinion still pretty fast flowing waterfall, especially for a backyard. So I'm going to try to slow that down a little bit more and also try to bring up the surface tension of it so that we have even less of these breaking or tearing of the water surface here. So let me go back to my setup and then change those things. So I guess we have enough of particles. We could increase this as well. We'll do that. So we have 17 million particles. And then in the dynamics, I'm going to set my strength of the surface tension to 0.1 and leave the rest as it is. Now let's go back to the liquid source and change this speed to 0.09 or something. Let's go and do that. Let's delete the cache again and start to simulate. And there we go. So that looks actually much better now. Export this simulation. That is the result. Looks much smoother and we have a nice water sheet going down. It looks really natural. Let's go and create our foam for our liquid. So we go to the foam rollout here and then enable foam. Say yes, so it creates a shader for you. And then the foam amount is set to 5 and that per threshold is set to 0.5 meters, which is 50 centimeters. I'm gonna leave all the stuff right now the way they are, but changing some stuff down here. So we don't need, for example, the foam volume because we are not creating beer simulation or something like that. And then the rising and falling speed, these are actually okay the way they are by the default settings. Then formation speed and so on, we can change it later on. We don't need that formation speed actually for this simulation. So splash and miss, we don't need that. And there is something else, and this is max outside age, which is set to 10. Let's set that maybe to just 1 second or something. So if they are going outside after a second, they will just die. Now, our fluid simulation is done, and we can, for the foam and stuff, we can just use resimulation. And that resimulation is really awesome because it is not going to resimulate your fluid simulation that you already have, and that saves a lot of time. It only simulates the things that you are selecting here. So splash and mist, foam and wetting. So I'm gonna get rid of splash and mist and leave foam and wetting, and I'm going to dynamics and turn on wetting this time so it will get created. We don't have to change anything here since if it is getting wet, it will stay wet for a long time. So we don't have to change any drying time or something. So we can leave all the things as default. Just turn on the wetting feature. Now, here we have output paths for the resimulation as well. So the base cache files, I wouldn't change that one because this is the same as the output path that we actually defined somewhere down here. So that is taking the data from this folder and is using that for the liquid simulation. And the output for our resimulated particles, that is something that you can change. And now we can go and start simulation. So this is done now, and in order to see the foam particles and stuff, we have to go back to the preview and then turn on particle preview, turn off show mesh. We don't need it for now. Now you see all these green ones are actually our foam particles. And under the simulation rollout, you can scroll down here, then it shows you how many particles actually we have for our foam. So our liquid simulation is using 294,000 particles, and foam is about 5,700, so about 6,000 foam particles, which looks like a good amount for this simulation. But we could go and change that amount and the way that those things are generated in the foam rollout again. So here we have foam amount, which is telling us how much foam per square centimeters should get generated in that area where it met this condition, the birth threshold. And that condition is zero 0.5 meters right now, which is 50 centimeters. And that basically means that the foam particles are getting generated wherever the liquid particles are moving faster than 50 centimeters per second. If the blue particles, let's say, are moving faster than 50 centimeters, which is zero 0.5 meters, then the foam birth will start giving birth to 5 foam particles per square centimeters in that area. And this will give you the total of your foam amount. So if you want to have less foam, you could go and say, I will change the amount to number 2. So then less particles will get generated in that area when they are meeting that condition of 0.5 meters velocity. Or you can just increase that velocity speed and say that the foam particles should actually get generated when the blue particles or liquid particles are faster than, let's say, 1 meters per second. And we can go and just give that a run. So I'm going to change the birth threshold to 1 and let everything else be the way it is, and just go and resimulate it and compare this foam particle amount down here, which is right now about 5,750, then to the next simulation that I am doing. By the way, here you see that these green particles are going outside of our grid, and this was that max outside age that we set, and I set it to 1 second, and that is still really long for them. So let's go back and set it to zero point 0.3 seconds so they will get killed a little bit faster, so we don't have to calculate them all the time. Now let me go here and just without killing the cache, this is important when you're on resimulation, just click on that play button and resimulate your simulation. And once again, make sure that in your output rollout, your grid velocity is activated. Otherwise, your motion blur will get ignored for your foam and liquid particles in your final render. Just again as a side note. So now let me go and resimulate the foam again. So I stop the simulation right here because when I take a closer look at that, rarely any foam particles are getting generated, which means that none or nearly none of those blue particles is going faster than 1 meters per second, which actually is a good thing to know because that means that we have a nice flow of our fluid, which is not fast and not too slow. So let's go and change or lower actually that threshold again to something like 0.63 or something, and then run the simulation to see what we get. So now we have about 1,700 particles, foam particles, which is, I think, good enough for such a small waterfall. So usually they are not generating so much foam. So let's say that we are happy with these results. And now let me go back to my liquid, oh sorry, to my show liquid system and see. Yes, so everything works fine. Now the next thing is creating pond water and make that interact with this waterfall water that we have here. For this, let me just bring in my rocks so I know where the area is. Now I go to my top view and then start creating another grid. I'm gonna make it as big as the pond actually is, and the height is again about the same. So let's go and change the grid size in the x-axis first. So go to the grid and then change this. We can bring it to this side a little bit. And the y-axis, that looks actually okay. Could be a little bit smaller. So something like this. Maybe we should push it back behind this rock. So we make it bigger again and push it to this side. So it goes behind that rock a little bit. So yeah. Okay. So the height of it, we can bring it up. It is, well, it's too high now. Go back down a little bit. Say about here, because that rock is, it shouldn't get overflowed or something. So now for the liquid settings, I'm gonna just increase the amount to 8 million particles. That should be good enough. And for our z-axis, I'm gonna go and jam minus. X and Y, we go and jam both sides, which means that the liquid will not get killed, but it will go and collide with these side walls and with the bottom, but not with the top. So then the next thing we're gonna do, and we have to do, is activating Cascade Simulator. So I'm gonna click on that, and now we have to go and select our first simulation, so it knows with which particles it should actually interact. Then we can go to our dynamic setup, turn off initial motion inertia, sorry, and then initial fill up, we're gonna fill it up to about 36% or something. And we don't need to fill it up for ocean. We are not creating an ocean right now. Step per frame, we could increase it. And the time, I'm gonna set it to the same time scale as our liquid simulation here. And the rest of it, we can leave that really the way it is. And foam and stuff, we go and generate that later on. Now, go to output and set the backup interval again to 5 and define a path for the pond water simulation. And now we can go and actually run our simulation. Again, make sure that in that output grid channel, the grid velocity is activated. So now let's go and select this simulator and run that simulation. So this is done now, but I changed some stuff actually during that simulation. So first of all, I was setting the X and Y container walls to jam plus instead of jam both. And that caused my liquid just to disappear. And for the z-axis, the jam minus, that's okay. So just make sure X and Y are set to jam both, and Z is jammed minus. So I corrected that one, and also increased the amount of the initial fill to 60% instead of 35. And this is what we got as the result. Now let me go and select number 2 and go to the preview rollout, turn on mesh and turn off particle view. And here we can see what actually happens and how that moves and stuff when those both simulations are interacting with each other. So it comes down and then it hits the water. So let me go and set the first one to mesh as well, so we can see what really happens here. So now the next thing we have to set up is the foam for the pond water here. So let me go and activate that as well. So foam enabled, say yes. So it will create the shader for it. And I'm gonna really leave that foam amount as it is, but change the bird threshold to a lower amount. So I'm gonna set it to 3, and I guess it will give me some good amount of particles here. And then for the formation speed, let's go and set it to 0.2, and then radius is 0.1. That is okay actually. The rest of it should work fine. We'll see. And then we have this half-life per second, which means after 10 seconds, the amount of the particles will get reduced to the half of those who will reach the 10 second after getting generated. So I'm going to lower this. I'm going to bring it down to maybe after 3 seconds, so they're not leaving that long. And maximum outside age, I'm going to set this guy to 0. I don't want any particles to go outside of this grid. So now let's go and activate resimulation for our second simulation as well, which is here. Say OK, uncheck splash, and then change the output path. So now with that said, I'm gonna go to preview again, turn on particle preview, and just turn off maybe liquid. So I don't want to see the liquid system here, but I want to see the foam particles and etc. So now let's go and start the re-simulation. And there we go. Now we have our foam generated as well. And that has actually a nice pattern, I must say. So when I go and make a preview again, we will see that in real time. So here it is. And that is what we have so far. And I must say the pattern of the foam is pretty cool. It came out really nice. And the amount of the particles is getting lower in a good amount of time, so it is not disappearing too fast and it is not living too long here. The flow looks acceptable, natural. So we can go and take a look at the final render and add materials to this fluid and see what that looks like. So let me go and select my simulators here, and then go to the materials. I have a water material here, assign this, and I don't have to assign any other materials since all of the rest of the assets, they already have the materials on them. So let me bring in all the other assets and then switch to my camera view, which is this one. And now I'm gonna move it to somewhere here maybe, and then render that out and see what that looks like. And there we have it. This is our result so far, and it looks pretty good actually. You need some color corrections and stuff, of course, but I like it how the foam came out and the motion blur works pretty good, and that looks good to me. Now, the next thing is something I would like to show you because that could happen in other cases and cause a problem. And this is having that box going outside of our stuff here. So when I go and render that again without, let's say, all the ground and the grasses and stuff, so let me get rid of this. So when I go and render that right now, we will see the water going outside of this pond, which in this case doesn't matter much because we can go and cover it with this ground and then you don't see that. But there are cases that you can't do that. You can't go and cover it because it is a container on a table or something. So there is really nothing around it to hide it. But you don't want to render the liquid out of your actual container. So let me show you first what that looks like when we go and just render this. And there we are. As you can see, that thing is just going outside and get rendered. Now we want to avoid this. And the way to do that is creating a container. So let me go to the top view again and then remove my assets here. Now I'm going to create a shape, just a spline actually, a freehand spline. So I can just go and draw that right in the center of my object here. So not outside and not inside of that pond, but right in the center of these rocks. So now let me go and solo this and then make it a close shape. So edit spline and then go and link those things together. There we have it. Now we have way too many vertices here, so I'm gonna normalize it. Normalize spline, show knots, and then I can bring that up until we have a nice shape going on. So that should actually do the job. Let me bring in back everything else and then push this line on the top maybe so I can see where it goes. And that looks pretty good. So now on top of this, I can go and add an extrude modifier. And extrude it up to something. And let me bring it down again to 0 and bring it a little bit below my grid, the simulation grid, so it covers it all. And then in the settings, just right click, go to Object Properties, and there we say it is not renderable. Then OK. And here we can go and then make it show as box, so we don't see the whole mesh. And now if we go back to our render settings, so I go and select my simulator here and go to my render rollout. Here we have the cutter geometry that we can select. So turn it on and then click on this button, select that box that we just created, which is now called freehand. And let's go and render this again. And now as you can see, that thing is gone. And everything inside of the container is getting rendered. That is a cool technique to let stuff disappear where you don't want them, and that works pretty cool. Now let's go back, bring everything in here, and create a final render out of that and see if everything looks fine. And with this, I would say that this is the end of our tutorial for today, and I hope that this tutorial is helpful and useful to you guys, and I'm going to talk to you in the next one. Wishing you a great and successful time. Bye-bye.